This is another example of finding the nth roots of a complex number. One of the previous little lectures I gave a little template to be able to throw over all of these, and I'll go through that template again. This is a slightly more difficult problem. So we've got w to the power of 4 is equal to minus 1 plus I, and we want to find w. Now, as I said, there are going to be 4 different answers. The first thing, this will be our z, and we need to express it in the terms of re to the I theta. So we've got to find out what this is into. This is presently in Cartesian form. We've got to actually convert this into polar form. So the first thing is to find r. R is equal to mod z, and that's the square root of minus 1 squared. Now the y is equal to 1 plus 1 squared, so that'll be equal to root 2. Okay, a quick little sketch, and I think they're invaluable, these little sketches for these. So this is my real, this is my imaginary. Where in which quadrant is this looking at? So we got minus 1 and I, so there it is there. So this is pi on 2 and this is pi, so it is going to be somewhere between pi on 2 and pi, my angle of theta. So there's theta. Minus 1, so this is out 1 unit, so this is minus 1 here, so that's 1 unit from there to there. And this is up to 1, so that's 1 unit from there to there as well. So once again, if we work out what alpha is, we can take alpha away from pi, because pi is all the way around there, and then take alpha and that'll give us theta. So to work out alpha, we've got the tan of an angle, and we disregard all signs when we do this. So we know that the tan of alpha is equal to 1 over 1, which is equal to 1. And we go back to our and think, okay, we know that one, because we've got our little magic triangles. This is pi on 4, right angle, that's pi on 4, we've got 1, 1, root 2. And the angle that has a tan, opposite over adjacent, of 1 over 1 is pi on 4. So therefore alpha is equal to pi on 4. I stress again, this alpha is not theta. That's only just a way to work out what theta is. So now we can say that theta is equal to, all the way around there, to pi, and we've got to come back alpha, so we go back pi on 4. Now pi is 4 pi on 4, so 4 pi on 4 minus 1 pi on 4 is 3 pi on 4. So that will allow us to actually work out that z is equal to, now root 2, it'll be r, now it'll be root 2 e to the I theta, so that's 3 pi on 4 plus 2k pi. And I think probably it would be better, rather than using a radical sign, square root sign, would be to express it as a fractional index. So that's 2 to the power of a half e to the I outside of 3 pi on 4 plus 2k pi. Okay, so now we can put it together, and we've got w to the 4 equals that. And our next step is to find the 4th root of both sides. So the 4th root of w to the 4 is just w. To the half, e to the I outside of 3 pi on 4 plus 2k pi. So there's my z, all raised to the power of a quarter. Okay, now when you've got two things multiplied together and all raised to the power of p, that p is going to be multiplied by both those powers when this is a multiply. So that's a to the np, b to the np. Here we've got 2½ times e to that. So this quarter's got to be multiplied by that, and that quarter's got to be multiplied by that. So we've got 2½ times a quarter, multiply the numerators, multiply the denominators, 1 times 1, 2 times 4 is 8, to the power of 8. E to the I, we can make this all in the numerator, 3 pi on 4 plus 2k pi, and that'll be all over 4. So that is all in that bracket is the index with I at the front. Okay, the fourth step of the template was to substitute in values for k, starting at 0 all the way up to 1 less than n. Now it was w to the 4, so n was equal to 4, so we're going to go k is 0, k equals 1, k equals 2, k equals 3. So k equals 0 will give me my first root, which we'll call w0, is 2 to the power of 1/8 e to the I outside of 3 pi on 4 plus, now if k is 0, all of that will be 0. And that'll be equal to 2 to the power of 1/8 e. Now 0 plus that is 3 pi on 4 over 4 will be 3 pi on 16. So that'll be I 3 pi on 16. K equals 1. W1 equals 2 to the power of 1/8 e to the I outside of 3 pi on 4 plus, now k is equal to 1, so that'll be 2 pi, and this will be all over 4, equals 2 to the power of 1/8 e to the I, a little bit tricky here, 3 pi on 4, now 2 pi is 8 pi on 4, so 8 pi on 4 plus 3 pi on 4 is 11 pi on 4, and then you've got to divide that by 4, so it'll be 11 pi on 16. So we keep on going up to n minus 1, so we're going to go up to k equals 3, so we've got 2 and then we've got 3 to go next. Okay, so this will generate the third fourth root, which we're going to call, just to confuse you, we're going to call it w2, is equal to 2 to the power of 1/8. And the reason that is we start with 0, 1, 2, 3, so it is the third root. E to the I outside of, go back in here, and we're going to put k is equal to 2, so it'll be 3 pi on 4 plus k is equal to 2, so that'll be 4 pi all over 4. Don't forget all that bracket is the power. So that's 2 to the power of 1/8 e. 4 pi is actually equal to, something over 4 will be 16 pi on 4. 16 pi on 4 plus 3 pi on 4 will be 19 pi on 4. And 19 pi on 4, you'll divide that by 4, so it'll be 19 pi on 16. And lucky last, k equals 3 generates the third w3, which is the fourth root, 2 to the power of 1/8 e to the I. Instead of that k there now, I'm going to put a value of 3. So it'll be 3 pi on 4 plus k equals 3, so that'll be 6 pi all over 4 equals 2 to the power of 1/8 e to the I. Now 6 pi as something over 4 will be 24 pi over 4. 24 pi on 4 plus 3 pi on 4 is 27 pi on 4. And when you divide by this 4, it'll be 27 pi all over 16. Okay, now just looking at the 4 roots, you notice that the mod, or the length, is always 2 to the power of 1/8. And we go e to the I. Now the modulus is 3 pi on 16, 11 pi on 16, 19 pi on 16, 27 pi on 16. And you can see what's going on here. There is actually a progression. 3 pi on 16, 11 pi on 16. So they're actually differing by 8 pi on 16. If you add another 8 pi on 16 to that, you get 11 pi. Now add another 8 pi on 16, you get 19. You add 8 pi on 16 to that, you get 27 pi on 16. So they're equally spaced around a circle of radius 2 to the power of 1/8. 2 to the power of 1/8 is approximately 1.09. So we'll quickly draw an arcane diagram. Real, imaginary axis. We'll draw a circle. 3 pi on 16 is, well, if it was 4 pi on 16, it would be exactly halfway. So 4 pi on 16 is a quarter of pi. Pi on 4 is 45 degrees. So 3 pi on 16 is just going to be slightly less than halfway between 0 and pi on 2. So I'll draw out there and I'll put W0. Then we're going to add and we'll get 11 pi on 16. 11 pi on 16 will be up there. 8 pi on 16, which is the difference, is actually pi on 2. So that'll be a right angle. So 8 pi on 16 is the difference between each of these 4. So that's actually a right angle there. And that'll be W1. And if that's a right angle, that means we go straight through there. We're going to get W2. So that's a right angle. That's a right angle. And this will be W3. That's also a right angle and a right angle. So they're equally spaced around the circle. The radius of the circle is 2 to the power of 1/8, which is the modulus. And the argument increases by 8 pi on 16, which is pi on 2 as we go around. So there are the 4. We'll go back and have a look at what the question asks. Find all 4th roots of that. And we've come up, expressed them all there in polar form, and then we've done an arcane diagram showing where they are spaced around the circle.